Telephone keypads actually give us a great example of the difference between a function and a relation. This is a challenge problem from Larson's Algebra 2. For the numbers 2 through 9 on a telephone keypad, seen here, we're going to draw two mapping diagrams. One is mapping numbers onto letters, and the other's mapping letters onto numbers. And we want to see if both of these relations are functions. Maybe neither of them are functions, maybe only one of them is a function. Just to make sure it's clear what we mean, if we're mapping numbers to letters, for example, the number 2, looking over here in the picture, the number 2 would map to A, and to B, and to C. And if we're mapping letters to numbers, for example, D would map to 3, and O would map to 6, just for a couple of examples. So here on the left, I'll draw the mapping diagram that maps numbers in the domain to letters in the range, based on the telephone keypad. And over here, I'll draw the mapping diagram that maps letters in the domain to numbers in the range. I'll show you the first few in each mapping diagram just to make sure the process is clear and you can try finishing it yourself before we discuss the conclusion. So if we're mapping numbers to letters, then the number 2 is going to map to the letter A. As you can see in the picture, 2 maps to A. It also maps to B and C. So we'll have an arrow mapping 2 to B, and an arrow mapping 2 to C, and the other numbers will proceed similarly. As for mapping the letters to numbers, we see that the letter A maps to 2, and B maps to 2, and C maps to 2. So I'll draw those arrows now. So there are the first few arrows. Once we finish this up, it's going to be pretty messy. There's a lot of mapping going on here, but I'm going to go ahead and finish it, and then we can discuss the conclusion. All right, that was fun. Here are our two relations. Let's look first at this relation that maps numbers from the keypad to their corresponding letters. Is this relation a function? The answer is no, because to be a function, each input needs to have exactly one output. Each element from the domain needs to have exactly one output in the range. In this case, we see 2, for example, maps to 3 things in the range. That's definitely not a function. The number 4 maps to 3 things. A couple of these numbers, 7 and 9, map to 4 things in the range. A single instance of something in the domain mapping to multiple things in the range means that the relation is not a function. So this most definitely is not a function, mapping the numbers to the letters. This is the mapping of letters to their corresponding numbers, and this is indeed a function. Each letter, if you look at the keypad, is present on only one number. So in our mapping diagram, each letter maps to exactly one number. G, H, and I, for example, all map to 4, but that's fine because G, H, and I all have exactly one output. It doesn't matter that their output happens to be the same. They each have one defined output. So this mapping from the letters to the numbers is indeed a function. Here are those conclusions again. This one is not a function because there are elements of the domain that map to multiple things in the range, and this is a function because each element in the domain maps to exactly one element in the range. Let me know in the comments if you have any questions, and be sure to check out my Algebra 2 course and Algebra 2 exercises playlists in the description for more. Thanks for watching.
Couldn't even open myself up for an instant. What's the law? It's regular. I regulate my integrity. I'm a secular anesthetic from my own effigy. I didn't try just to be regular.